Hearty welcome to all knowledge seekers to my channel. This is Dr. Madhusudan Rao Kadapa. In some other videos, I have explained some classical problems on single server queuing model. In this video also, I am going to explain a classical problem which is most common in production oriented organization. Here the problem is that in a company, the fitters of maintenance department draw parts from stores. So maintenance people require spare parts which are necessary to carry out the replacements of the broken down machines. So they draw parts from a stores which is at present operated by a single storesman. So there is one storekeeper. So this is a single server model. The foreman of the maintenance department is concerned about the time spent by fitters in getting the parts, because once the mechanics go to stores, it may take some time for them to get the required spare parts, because the storekeeper has to search for the items and then he has to get it. So naturally the maintenance department people have to wait. So the time spent by them is significant, and he wants to know if the deployment of a store assistant would be worthwhile or not. So with a single storekeeper, he has to wander through the stores each and every time, and he has to find the parts and then get it done, get it issued to the fitters. So it takes a long time for him. Suppose if he has an assistant, so that assistant can help him in picking the required parts from the located bins or racks as per the guidance of the storekeeper. So anyhow, storekeeper and the assistant put together will work as a single server, and we have to check whether employing an assistant is worthwhile or not. Now the characteristics of the queuing system are: first, simple queuing situation. That means it's a simple queuing process without any much complications like queuing network or anything like that, series or parallel like that. And B, fitters cost rupees 150 per hour, storesman cost rupees 100 per hour, and can handle 10 fitters per hour. So the storekeeper alone can handle 10 fitters per hour. That means that is his service rate. And an assistant can be hired at rupees 75 per hour, and he can increase the capacity of stores to 12 fitters per hour. So without assistant it is 10 per hour. With assistant the service rate will increase to 12 per hour. On an average 8 fitters arrive at the stores per hour. So this is the given information. Now a simple queuing situation exists means arrival and service times follow exponential distribution. This is m/m/1 single server queuing model. Now to solve this problem, we can use any of these two parameters. One is the expected number of fitters in the system, that is LS, with assistant or without assistant, because as lambda is same, that is lambda means the mean arrival rate is same, but mean service rate varies with or without a store assistant. This is one parameter. The other parameter based on which we can compare the total costs with and without an assistant is average waiting time of customer in the system. Now let us proceed like this. See, here we have the mean arrival rate of fitters at store lambda equal to 8 per hour, and mean service rate without an assistant is mu which is 10 per hour. Mean service rate with a stores assistant is 12 per hour. Cost of fitter per hour is 150. Cost of storekeeper per hour is rupees 100. And cost of store assistant per hour is rupees 75. So the hourly costs of fitter, storekeeper and store assistant are given. And now first method is to compare the total costs based on LS, that is expected number of fitters in the system, with and without stores assistant. So without the stores assistant, LS equal to lambda by mu minus lambda, which is equal to, on substitution, it is 4. So total cost per hour, if you calculate, waiting time cost of fitters plus cost of storekeeper. So there are 4 fitters waiting. Waiting means they are in the system. That means those which are in queue as well as the ones whose service is in progress. So 4 into 150 plus rupees 100 for the storekeeper. Altogether it is rupees 700 per hour. This is the total cost without a store assistant. Now, if we deploy the store assistant also, then the service rate will increase to 12. So for the new service rate, that is revised service rate, we get LS equal to lambda by mu prime minus lambda. On substitution we get 2. So the expected number of fitters in the system is 2. Now total cost per hour is waiting time cost of fitters plus cost of storekeeper plus cost of store assistant. So 2 into 150 for fitters plus 100 rupees for storekeeper and 75 rupees for store assistant, put together is 475 rupees. If you compare the total costs with and without hiring a store assistant, without a assistant it is rupees 700 and with a store assistant it is 475. So here the total cost is less with a store assistant. So there is a saving of rupees 225 per hour. So the proposal of hiring a store assistant to reduce the waiting time and cost of fitters is worthwhile. Now instead of going for LS, we can use WS, that is the average time spent by a customer, that is a fitter in the system. Here we have without the store assistant. If you take lambda equal to 8 and mu equal to 10, then we get WS equal to 0.5 hours, which means the total cost per hour equal to waiting time cost of fitters plus cost of storekeeper as usual. So here the waiting time cost of fitters is found like this. Here 8 is the mean arrival rate of customers, that is on an average 8 customers arrive per hour. So on an average each fitter has to spend 0.5 hours in the system. So 8 into 0.5, this is the unproductive time. 8 into 0.5 multiplied by 150 per hour, which is 600 rupees plus rupees 100 for the cost of storekeeper, put together it is rupees 700. This is the total cost per hour. Now with a stores assistant, the service rate will increase to 12. So WS will become 0.25 hour on substitution. And the total cost per hour equal to waiting time cost of fitters, which is 8 into, because 8 customers arrive on an average per hour, multiplied by 0.25 for each fitter, multiplied by 150. This is 300 rupees plus 100 rupees for storekeeper and rupees 75 per hour for store assistant. Put together it is 475 rupees. This is the total cost per hour with a store assistant. Now comparing the total costs, we got the similar results here. The total costs with and without store assistant are same as that what we got using LS also. So on comparing the total cost, there is a saving of rupees 225 per hour. And this is what we conclude. From this we can say the proposal of hiring a store assistant is worthwhile. That's how we can solve the problem. Thank you very much. In some other video I will explain some other interesting concepts in queuing theory. Thank you.